Okay, so the problem that we are looking at right now is that we have two arrays which have already been sorted, and we want to figure out the median of the merged array. So they give some examples here. As usual, lead code gives useless examples. The first one is 1, 3, and the second array is 2. So 2 gets inserted into the middle of the 1, 3 array. So the merged array is 1, 2, 3, whose median is 2. Next, we have 1, 2, and 3, 4. When you merge them, the second one comes at the tail of the first one. So the middle two elements are 2 and 3, whose median becomes 2 plus 3 by 2, which is 2.5. Let's look at the constraints. So they're saying that let's call the length of the first one m, second one n, and they are within length of 1000. And then we have that their total length is at least one. So you will not be given the case that there is no number around. And these are the limits of the numbers that can exist. So let's just play around with a few examples here. So let's take a simple array. 1, 2, 3 is one. The second one, maybe I'll take it as 100, 101, 102, something like I'll just take it as length 3. So it would be the easiest problem in the world if we could do something with the middle elements of the two arrays. But here you can see that if you kind of merge them, it's not that the middle elements remain interesting, that it becomes the edge elements that are interesting. 3 of the first one and 100 out of the second one. So it seems that merging the two arrays seems to be a big part of the problem. So is this a problem in disguise, and the original task is to just quickly merge two sorted arrays? So let's take that to be kind of like the worst case version of this problem. Sorry, what I mean by that is that if we end up merging the two arrays, then definitely it is going to be easy to pick out the median from it. It's just the element at length by 2, or the two elements around the virtual length by 2. So then this brings to the question whether is it possible to do it in faster time than this? Is it possible that we don't need to do the full merger? So there as well, one question probably arises is that let's say in this scenario that I have okay, so let me draw a line here to kind of say that this was one example. Let's start again with another example, 1, 2, 3, and let's take the second array which has minus 1. Let's have it have a 2.5, and the third guy I'll keep it floating here. So when I merge these two, it's clear that minus 1 goes to the left of 1, 2.5 goes to the right of 2. So what becomes kind of concrete till now, that the array between minus 1 to minus 1 to 2.5. So let me actually draw this out for you, what I mean here. So minus 1, 1, 2, 2.5. This thing is set in stone. Any element that I have in the second array will not change this part of the equation. But let's say that the second element was, the last element here was 2.9. In that case, it becomes 2.9 and 3. Or let's say if it was 3.1 instead of 2.9. So in which case it becomes 3, uh, 3 and 3.1. So you can see here that it impacts just the tail of the merged array. So as we are doing this, do you get a feeling that if by chance you have merged enough of the two arrays, that you have gone past the middle of the merged array? So what I mean by that is, let's say M, the first array was 3 in length, the second one is 8 in length. If you have, sorry, not 8, 5. No, okay, let's keep it as 6 so that it works out to be odd right now. Yeah, so if the first one was 3 in length, the second one was 6 in length, and you merged a few numbers that you have figured out what the first five elements of the merged array is. Then whatever comes later in the as later as part of the merged array does not impact the first five elements at all. Do you see that? So in that scenario, what happens is that you are safe. You have actually figured out what the median is. The rest of the array is does not matter. So now this is just a factor. What I mean by that is if you don't merge the rest of the arrays, and let's say the merging of the first one is some order, and it's an order such that when you double it, it does not cause that much of a problem. So realistically, just leaving out half of the merger in terms of how you calculate complexity, it will not probably matter much. But practically it will, because you can just ignore the tail half of the two arrays. Okay, so then this leads to the question of how do we merge two sorted arrays, at least till their half. So I guess before we kind of start on this, maybe what we can do is we can just look at the first two terms of the two arrays. We'll keep indexes of both of them. We'll walk them, we'll walk along both of them. So we look at the first elements to figure out who's the smallest. That guy starts it, and its index moves forward because we've already used that element. So now we can move to the second element. So maybe instead of making this as boring, let's maybe call it, let's talk about it in this way. Let's say Sachin Tendulkar has a bunch of numbers, and let's say we have Virat Kohli has a bunch of numbers. So Sachin Tendulkar is holding his bunch of numbers in a sorted order. So maybe these are all the runs he has scored in his career, starting from the first to the second inning, to the last inning, and then we have the bunch of numbers that Virat Kohli has scored. So we first figure in our merged array, and then we are interested in their subsequent number. Now, at this point of time, we are still waiting on Virat Kohli's first number. So what we'll do is, if Virat Kohli's first number is smaller than Sachin's first number, then we'll continue. We'll put Virat Kohli here, and then we'll move the index one more step forward. And then I guess in this process keeps on continuing till we have exhausted the number of elements that we want to merge. So I guess that could be one strategy. And what we'll do is we'll keep the index for this variable, for this loop, as the one for the merged. So we start a merged this thing, and we have k equal to. So let's take k as 0, but I believe we'll have to start it as -1. And then if k greater than k largest, we'll break. And k largest, so here let's take m as len of nums1 and n as len of nums2, and then we'll have k largest is equal to m plus n by 2. So we'll do decimal division. So if k largest, now at this point we need to figure out if k largest is equal to m plus n integer division 2. So in this, I'll just give you an example what I mean here. Let's say m was equal to 3, n was equal to 2. So k largest would turn out to be 2.5, but m plus n by 2 in this way uh, would be equal to 2, and 2.5 will not be equal to 2. So that's the scenario that we'll take care of in the else block. And if let's say both of them, the sum turns out to be even. So let's say m was 3, n was 9. So then k largest would turn out to be 12 by 2, 6, and m plus n by 2. Okay, I'll call this by 2. It will also turn out to be 6. That's the case that we figure out here, right? So in this case, we have an even scenario. So in the even scenario, so 6 is the half of 12, but 6 represents the sixth element, but the two middle elements in this case, in the case of a even number of arrays, are 6 and 7, right? Because 7, if you consider the elements that are in 7's side, 7, 8, 9, 10, 11, 12. There are 6 elements on 7's team, and there are 6 elements on the sixth elements team, 1, 2, 3, 4, 5, 6. So in this case, we have that. Now, another slight detail in Python, we say that the index of the array starts from 0. So in this case, if k largest is 6, it's in this case, if we have that we have an even sized merged array, 6, the number 6 is actually representing the seventh element, and which is fine because we want to merge the arrays till the last element that will be relevant for the median, which is the seventh element. Now, in the other case, where we have an odd numbered thing, so what we'll do is k largest is equal to m plus n by 2 plus 1. So we'll just do that. So in this case of 0, 1, 2, 3, 4, 5. This will, like a 5 sized array, this will become 5 by 2, which is 2 plus 1, 3. But 3 will be the fourth element. Fourth is just too much. We only needed to go to the third element. So again, because of 0 indexing, this plus 1 goes away. Okay, so that is fine. And yeah, so when we bypass k largest, we are done. And at this point, I think what we can return is the, so just 1 second. Uh, okay, so uh, we'll return the median here. So let me just leave a exclamation mark here. I typically do that to tell myself if there is a piece of code I have not written yet. And I'll just write calculate median based on even or odd sized final array. So actually having typed this out, I think this is an easy problem to solve. So let me in fact introduce one more variable, merged len. So I'll call it m plus n. Okay. So if merged len is going to be divisible by 2, what I'm going to return is return merged merged of -1 plus merged of -2, because the last two would be the middle elements, and by 2. It's not by 2, it's by 2. LF, so in fact not LF, there is only one else block here, that it is the merge length is not even. In this case, I'll just return merged of -1. So that's all that would be. Okay, so now we come to the loop. So I start with ij equal to 0, comma 0, and then if nums1 of I is smaller than nums2 of j, what I'll do is merged dot append uh, nums1 of I, uh, k is equal to len merged and I equal to I plus 1. Else I'll append into it uh, nums2 of j. In fact, this len of merged, I believe this will happen in both cases, so I can bring it outside. and J will be the one that will move forward. So in the first case, I found that Sachin Tendulkar's score at this stage, as Sachin Tendulkar has a lower score, so I'll take his and I'll move forward in his list of scores. In the second one, Virat Kohli has a smaller score, and I'll move forward in his set of scores. And this will keep on going. And by the end of it, I believe what will happen is if you sum together I and J, and remember, I and J are indexes, so they're not actually talking about the number of elements we've seen in Sachin Tendulkar and Virat Kohli, but there's a minus one involved as well. So if I kind of add them together and add two to it, that's the total number of elements I've seen across Sachin Tendulkar and Virat Kohli. That should be equal to K plus one, because again, K is an index, and to get the total number of elements you've seen, you have to add one to it. Okay, so I guess that would be the solution strategy for this question.